All right. Fantastic. Well, Vulcan, are you ready to present?
I think, can you guys hear me?
Yes, perfectly.
By the way, there's a big construction with drills and whatever is
Oh,
going on. So
sorry.
I'll get closer to the microphone and I'll trust it's, whatever circuitry can
Mhm.
block my voice from the construction. But if I sound like deeper, that's because of the microphone, not me.
Okay.
Okay, so
Uh,
let me share my screen as well. You cannot start screen share while the other participants are sharing. Who's sharing?
I stopped sharing. Try again.
Okay, let me try it again. Uh, this test up. Yep. Can you see it?
Yes.
Okay, so I have a like this is a slideshow that I repurposed for like external communication. It's a normally a VMware internal slideshow, and I put my company as Broadcom because it may become Broadcom soonish, but right now I'm still a VMware employee, just for the record. So this is about like VMware Secrets Manager, and it's a plenty of slides. I rush through some of them because I don't want to do a full blown talk. So I'll first talk about what VMware Secrets Manager is. I'll do a high level overview. Then maybe cover a couple of use cases. And I have a mini demo that does a federated secrets sharing, which I was able to reset the cluster and like fix it. I kind of shared my pains in the channel, which Evan kind of responded. So I look at it later about the a timing out of certificates issue, which is normal, I guess, but still. So what is VMware Secrets Manager? So it started its life as Aegis. If you know the backstory, it's like a secret store that uses SPIFFE and Spire as the identity control plane to dispatch to solve the identity part, so that it can dispatch secrets securely by establishing MTLS connections that is founded by the use of Spire. Essentially, that's that. The benefit of it so far, with when compared to alternative solutions, is we typically use this on the edge deployments, and it's really since we are leveraging Kubernetes primitives and also SPIFFE, the footprint is really low. I don't have to like if you consider, for example, HashiCorp Vault for a highly available distribution, I need to deploy like six console nodes, three Vault nodes in three different availability zones. With Secrets Manager, VMware Secrets Manager, it's much leaner and it's much easier to operate from an operational perspective as well. And like there are a bunch of things that help. So I started it like a year ago as a hobby project by hacking things around. Then I kind of championed it through getting adopted into VMware open source. And when it became a VMware open source mainstream project, I got a team behind it. So we have four core contributors and a second security person to look after the security part along with me. So like I am wearing all the hats. I am doing the R&D. I am doing these talks and communication and whatnot. But there's a team behind it as well. It's not just me at the moment. So these are from the early days. Quotes from like Evan, Ramiro, Andrew, Eli. Like the usual suspects. But like the initial sentiment was good, and from that point on, like we added more value, and I'm hoping, and I'm getting requests about how I can use this in my system, in my like it's getting more production adoption, which makes the commuters and the contributors and myself happy as well. So the see in the security aspect, Spire handles most of its PV and Spire, and we added this FIPS compliance layer for some three-letter customers that might want it essentially, but by default it's not FIPS compliant, but it's a feature flag. If you want, you can get a FIPS compliant images, assuming you make Spire FIPS compliant as well, which is a ticket going on its own regard. Other than that, there are a bunch of. I skipped this one. It's like a feature list. So comparing it with Vault, I'm not going to dive into too much details, but the main comparison with Vault and also other similar secret stores is the ease of deployment. To deploy a HashiCorp deployment, like I said, you need to open up, lots of firewalls. You need to configure a lot of stuff. Again, that can be automatable, but still on the edge, the energy footprint is really important. The amount of RAM you use, the amount of CPU you use is like it's expensive essentially because those stuff are used for other stuff like signal processing or like doing, mobile handovers and other algorithms. So the less you can do with your resources, the more you can like make the service providers happy essentially. So that's how like the secrets manager deployment is done. So we have a sentinel, which is like the bastion host. You shell into it and enter like register secrets. Safe is like you can think of it as a secret store, and the workload is out of the like system. It just fetches the secrets that is assigned to it. So the only critical thing is this safe component that stores the secrets, and also Spire as the control plane. But Spire is in any deployment, I feel Spire should be a given because you'll have to establish some sort of MTLS, and Spire really helps it, make it better. So, like, I don't feel it as an additional, footprint. So, it considered all of those. It is really, lightweight. So, ideally, it's running on water, like 1,000 of a CPU core, 8 MB of memory. And when I load it with, lots of secrets, the memory consumption didn't go too much. Like the highest I was able to see was 20 MB with, thousands of secrets. It's still manageable, essentially. Um, so that's that one. As a high level overview, like I said, we have the Sentinel, which you kind of shell into it and register secrets. And having a separate component like this gives an additional trust boundary around things as well, because like Sentinel is the only place that you can register secrets and also like modify secrets essentially. So after you are done with your secrets, if you kill Sentinel, then there is no way getting into the system. Like you can, if you try hard enough, maybe you can figure out a way into safe, but safe is it's a distroless image. So you really need to find your way into it and like exploit it like as a cluster admin. And if you get the cluster admin privileges, then like you have bigger problems essentially. So that's that one. Spire kind of dispatches identities to all of these components, including workloads. And like this is typical workload API. I won't dive into that detail. And this is also typical Spire exchange. I'll just quickly overview it, but all of us know and aware about it, I guess. So the workload asks for its identity, then Spire checks, its identity based on like whatever attestation that we do. Then we give it an ID, and also other components in the system like the Sentinel also has an ID, Safe also has an ID, so that the workload can ask for the secret and get its secret essentially. And this is the typical exchange, like both of them get their X509 certs, and then the Sentinel can register to Safe. But since these have different IDs, I'll skip this one. Uh, for example, a workload cannot register a secret because workload is not Sentinel essentially. It can only read. So based on those IDs and SWITs, we can do kind of a poor man's, RBAC, I guess, or ABAC, whatever you call it. I'll skip this part. So we were thinking about planning to do like external integrations, like bidirectional, like instead of, for example, or along with using an in-memory secret store, we were planning to like synchronize it with KMS, Azure Keyword, HashiCorp Vault, and things like that. Then HashiCorp's business software license came, and I felt like I am doing a secrets management stuff, or we are as contributors, and we kind of sort of may compete with Vault if you do this. So we kind of took it out of the list of, upstream integrations just to be on the safe side. I would very much not want, a big company sue me. So, so that this is the case. Like if when we communicate with, Hashi and they clarify that their intent is to keep a, collaborative ecosystem, we might add them back into this list. But right now, I don't want to have them at this moment, at least. But that's that thing. Let's see. Yeah, multi-cluster federation. This is a work in progress. I'll do a quick demo. And I have kind of a setup down here. So I have two clusters for that thing. I put Sentinel in one cluster, Safe in the other cluster. There's and then, there are different kind of, spire topologies, federated spire, nested spire, and whatnot. I just wanted to test, whether federation works in this case. It kind of worked, but I also had to open up a bunch of issues on the secrets manager part, which we'll get to them, but it's still demoable. And like in the setup, I have Sentinel and the workload in one cluster and Safe in the other cluster, and we will do secret exchange. Uh, but since it's a spire, the where you put your workload doesn't matter that much, as long as there is some network connectivity and as long as you provide, SWITs and bundles to the workloads and they can authenticate themselves, you can put them anywhere. One of them can be in Azure Cloud, the other can be in GCP, the other can be on your, on-prem Kubernetes, and in theory, with some latency, things should work, I guess, and we can test them later down the line. But at least, the initial multi-secret federation demo proved itself to be, promising at the very least. So this is kind of a use case, but it's not the best use case I can come up with. Like, I would not typically, I would not want to, exchange secrets like this because that's where SWITs are for. But still, if you want to dispatch secrets for, I don't know, legacy reasons to different workloads in different clusters to exchange this kind of a communication with a federated Spire slash secrets manager setup, it should be possible with some kinks, I guess. So that's one. So there are different ways that the secrets manager can fetch. The workloads can fetch secrets. One of them is using the SDK. There's a Golang SDK that is heavily piggybacking on the Go SPIFFE library, which can directly fetch secrets from the store, assuming it has the correct identity. And the other is just leverage a sidecar and let it write to a in-memory volume so that the pod, the workload can be oblivious about whether there is a secrets manager managing it or not. It can just read whatever secrets is in the path and just parse it essentially. That's one other way to consume a secret. And there is also this transformation thing. So if I am using like a kind of a traditional setup or like a legacy setup, and I am leveraging heavily on Kubernetes secrets, but I want to still use secrets manager as a transitionary process, I can define a secret as kind of a JSON and put a Golang template transformation on top of it, and it will map into an actual Kubernetes secret, and then I can bind that secret however I want, like as environment variables or as a volume, and consume it in my workload. And like you can add extra controls around it too, like when the secret changes, like kill the workload, restart the workload, and things like that. But essentially, it has this kind of a secret value, like Golang template transformation based secret management possibility as well built into the system. So that's that one. And for template transformations, there's this, dash F YAML format flag. So like we have JSON YAML, and if it doesn't fit anything, it will do some kind of a free-form transformation. But it's useful to, like, if the consumer expects like a key value pair YAML like form, but the secret creator produces a JSON secret, then this transformation is kind of possible as well. What else? Future plans. I won't dive too much into it again because of the time constraints, but if you go to vsecond.com/docs/roadmap, you can see like the 1 year ahead of plan that we have done. And on this link, and I shared this slide on the Slack channel as well. If you go to this link, there's like an hour worth of video content that you might want to watch if you have time, like it's chunked into 10-minute pieces for ease of consumption. Oh yeah, and that's that one. I'll jump into demo, and after that, if you have questions, we can discuss. So this is that one. So I have like four screens down here. The left half is the cluster one in the diagram that I showed you before. In where is it? Let's come on here. And the right hand side is the cluster two. And I have like tailing three different logs. The bottom one is the Spire server on cluster one. The bottom right corner is the Spire server on cluster two, and this is the secrets manager safe, the secret store that is logging. So I have a bunch of scripts. I'll just run them as part of the demo because I don't want to risk any funky stuff on a live demo essentially. So first I'll show what it is. For example, if I do a list secret, it is like executing Sentinel and safe-l, and safe-l is just L is for list, so it will like list whatever. Because I need to just do this. Yeah. So it will list all of the secrets that the safe knows in a JSON form. The thing is, like when I'm interacting with Sentinel, I cannot get the value of the secrets. I can get only which workload it is associated with, and this is by design. Like I don't want anybody to get the secrets in plain without even if they are the administrator. So there are user stories to like for the administrator to provide a public key and encrypt the result and give the secrets encrypted with that public key. So if they want to look like decrypt them with their private key, it's their issue in that case. So that's that one. So I can register a secret. But since I have a secret already, I want to first delete it so that I can show how it is registered. So to delete a secret, it's still same. We use the save command, give the name of the workload, and kind of then pass the -d flag, and it will delete the secret. I'll just run it. And how do I get those names? If you ask, it is from the cluster SPIFFE ID. So if I do a cluster SPIFFE ID, I have right now a Sentinel and the inspector. Inspector is my workload. So if I do clusters PPID in not this one, come on, inspector, it will show that it has this kind of an ASVIT. So in behind the scenes, we parse this ASVIT, and if it's in the format of workload/example, then we deduce that the name of the workload is example. So it will fetch only the secrets that is assigned to the workload with name example, essentially. That's how the dispatching is done. What else? I deleted the secret, so I can register a secret right now. So registering a secret is same again. Like this is the most primitive way. You can do transformations and templating and all, but at the most basic way to register a secret, you provide a name of the workload. You may or may not provide the namespace. If you don't, it will default to default, and then you provide the secret. So if I do a register secret, it will register the secret, and if I list the secrets again, it will show the secret. But how does the workload fetch the secret? I can show you that too. What? No resources found in the default namespace. Because this is the other one. I'll just run this one again. Kubectl get po. So I have this vsecum inspector workload. So I can it has a binary that can show what secret that has been assigned to it. So it is like I can just run that binary in this inspector workload, which I'll do with secret, and it will show that the secret to the workload has been successfully registered. What else do I have? I don't need to print bundles. The rest is, yeah, we deleted secrets, registered secrets, so it's more or less it, I guess. Like I have other stuff, I can show other stuff as well, but I just wanted to give a really basic example to show you a like glimpse of what it can do. But essentially, that's how secrets managers work in a federated multi-cluster fashion, essentially.
That's awesome, Volkan. Thank you so
Yeah,
much.
sure.
Yeah, really, really fascinating stuff. Especially like I feel like Vault started, a long time ago when this stuff was really hard.
Hmm.
But now that we have Kubernetes, we have SPIFFE, you can
Yeah,
actually use those as a foundation and build the same thing that works a lot more smoothly with those other
yeah.
technologies.
And then the
Just by
benefit
putting.
that I found is like since we are using SPIFFE and also all the other controllers and Kubernetes primitives, I don't have to like I can not cut corners per se, but I can reduce the footprint because I'm only concerned about storing secrets, and storing secrets at a really high level is just have a in-memory key value store, and that's it. So the footprint reduces so much. Managing it is so easy. Right now,
Mhm.
I have only one component that I need to make sure that it is, when I kill and revive it, it will fetch all the secrets back, and that's the secrets manager safe, which is backed by a persistent. It is highly recommended, but optionally backed by a persistent volume, and all of the secrets in the PV are like encrypted. So when the pod is evicted and it recreates itself, it will fetch and decrypt those secrets from the PV. So it makes it really, like, to me at least, it makes it really easy to manage, and like that also is good because uh like we are at least in the telco business group that we have, or in the RIC business subgroup that I am in, our ops team is dealing with lots of stuff, and managing a full-blown like secrets management architecture on top of what they do is will be time consuming. We might require additional development resources, which in this case we don't. We just put it and forget it.
Awesome, thank you. And then the other question I wanted to kind of ask
Mhm.
is around you came up with this idea before you worked for VMware, and somehow you built up momentum and got users just completely on your own, which is incredibly impressive.
Mhm.
Just as a side project, how did you do that? And do you have any advice for other people who maybe
Oh,
see a need and want to build something?
I don't know. Like that's a really deep question because like how do ideas come? Like how do you invent? How are you
Mhm.
creative? Uh, it's if I look into like my so far my other inventions that I have done or other ideas that have come up with, it requires getting inputs from lots of stuff. So, but I personally I just don't do technical stuff. Like I read fiction novels. I really like uh, fantasy kind of things like dragons and things like all the nerds. I guess that's one thing. Get any kind of input anywhere, wherever because you will never know what kind of mesh of ideas can like trigger something essentially. And the other thing I do is like I, as best as I can, try to it's also counterintuitive, but I try to get physically away from this entire setup as best as I can. I go to a hike, go to a walk. That kind of,
Mhm.
I don't know, either it pushes things into the back process, so your brain thinks, but you don't know that, it is thinking. And also, the other thing I do is to be aware of. I have all so far, like since maybe last 15 to 20 years, I was always not obsessed, but interested in, how what I create will be used rather than the like ivory tower pleasure of creating something. I want people
Mhm.
to consume it, and then I pay attention to what people do, what their pain points are, and whether like even prototyping something that may solve stuff can help address their pain points. And the other thing is like prototyping is good, but sometimes in the perfectionist in people's can like try to push it to like production productize it, make it perfect. Like you should be it takes time to feel comfortable to make an idea, push it away because it's like garbage, and make another idea, like emotionally detaching your creation from yourself. That also helped me to, I don't know, be more creative, so per se. Not sure, like it's really a deep question, but I was able to give some glimpse, I guess, at least.
Yeah, definitely, definitely. And then you built this community around it and found users
Yeah.
as a side project, and now it's part of VMware. And I'm sure it will
Yeah,
grow
it's like
rapidly as part of VMware, but
after a while, like after uh the reason I had to make it a non-side
Mhm.
project was because VMware has a policy called responsible usage of resources policy, and now I'm building it. It's growing, and it's not eating up from my VMware time, but still I am leading something that VMware doesn't know about. It's kind of can be on the gray zone. So I said, hey, I have this and I want to open source it, and I would very much like it to open source under VMware umbrella rather than some other umbrella. But still, and if not possible, I can search other ways and whatnot. So I had to initiate that discussion, but it's good to I don't know. It's satisfying to have the feeling that I was at least able to grab attention of a community around it and like make it grow. It's fulfilling, I guess.
Yeah, I'm sure they'll be able to help it grow more rapidly as well. Because
Yeah.
ton of resources.
After like that's also like not everybody has the chance to back their projects by large company, and I was lucky to have that privilege, so to speak, both in Cisco and in VMware. In Cisco, the project was not so visible, so not many know it, but in the Secrets Manager is more visible. The thing is, like, when you do that, like it's really hard. Like you people like within the company, the contributors inside the company, like don't even though they don't contribute full time, they are more active, and they can find more excuses to do the work in the company time than other contributors, because for other contributors it's like mostly in their hobby time or self time. But right now I know that I'll be using this in telco cloud, so I can put some work around this project in my regular sprint buckets, essentially, which is good. Doing open source in company time, it's I don't know, it's a good feeling.
Fantastic.
Yeah.
Cool. Well, are there any other questions for Vulcan?
I have a couple of questions. Yeah, just trying to understand like how Spire fits in that system, how it's used. I was curious to know like how the bootstrapping works with in Spire. Like you need to start getting SVs and all that. I'm not sure how the entries are registered and who does that. Is the system? Is the user? How that
right now, like the Helm charts and also the YAML like examples that the project has assumes not assumes, but deploys a Spire mostly in its default settings. So it is not a production grade Spire, and the assumption is whoever is deploying Spire knows how to manage based on their own needs and wants. Secrets Manager has its own bootstrapping process, because it needs to store a master key to encrypt all of the secrets into the persistent volume. So there is that process, but that's independent of Spire, essentially. I don't know if it helps answer the question.
Yeah, and also I'm not sure if I get it, how Spire is deployed as part of the secret manager. Is something that the user needs to do, or is something that it's also managed as part of the deployment of the secret manager?
Right now, like I said, there is when you do make deploy or like deploy via Helm chart, it deploys a Spire along with Secrets Manager as well. But we haven't done a like safety analysis about how safe it is, or whether it is robust enough or things like that. So I would assume, but there's also an option, like this is the fast route. Like when you compare it with Helm chart, this is like the light version of the Helm charts rather than the hardened version of it. The hardened approach I would suggest would be to deploy Spire in a way that aligns with the version that comes with the bundle, but harden it with your own requirements, because sometimes you might want to like put the upstream certificate to a cloud key management system, for example, to make Spire more secure, or you might want to put Spire into a different cluster to like put a different security boundary around it. So right now, like for two reasons, one of them is like we are still like all of us are contributing to it as contributors in our mostly spare time. So time-wise, thinking about how to secure Spire and also like the making progress in the product was too much for everybody. So we put it to like later down the line, essentially. But yeah, like if you have a secure Spire, you can just in theory plug it on top of it and start it working essentially. And in this demo, actually, that was what I did. I didn't run the make files. I didn't run the Helm charts. I folder by folder. I can show it actually. Let me share my. Where is this one? Desktop. Share my screen. So clear. Where am I? No. I'll go one way up. Clear. So I have this, inspector, sentinel, and spire. What I did was first I cd'd into spire, and then I did a kubectl apply -k dot. I can still do it, I guess, because it will just reconcile. I did this, and after doing this, I deployed whatever else, like the safe and sentinel and the sample workload. So as they can be deployed separately as different Lego pieces, but at least there is a starting spire that you can just take a server, a spire server, sorry, spire server.yaml, I don't know, less. So you can take this as a starting point, for example, and then configure it and do stuff with it essentially. But right now it's not it builds and it runs as a spire that secrets manager can consume, but it's not the most secure. It can be made harder. You can harden it further depending on your needs essentially. Boom, boom, boom. Yeah, that's that.
Makes sense. That makes sense. Yeah. And finally, I was curious also to know if you could mention what have been the main challenges that you had integrating software with Spire, or maybe what are the challenging things that you had and some things that you saw that make it easier, and what are the things that made it easier and difficult?
That's a good question. The easier part was before coming to this point, I had to investigate, what's Vault and other solutions to be deployed, and I realized that if we had to deploy Vault, it will be kind of a maintenance nightmare. So diving into this, one challenge would be, I don't know, sometimes. Not always, because Spire documentation is fairly good, but I had every once in a while finding the correct example to copy around, which then I was either bugging Evan or Li to help me essentially. That was one challenge, but it's not a big annoyance. In time you can figure things out, and the code is really neatly written around Spire. SPIFFE is an excellent library that helps things. That helps that you don't need to invent a lot of stuff yourself. It's already there essentially. That's a good part, I guess. The challenge on my end, and this is being recorded, so I'll try to be careful, was convincing and persuading people. So even to make the project open source, I had to work for even not that, even to get a name of it, to decide which name to use, it took 3 months. It's amazing. I'm saying, hey, I want to use Aegis because I like the Aegis. There's a community around it. I don't want to lose the Aegis community just to rename the project. And they say, no, we cannot use it. Why? Because of this and this and that. All right. Then let's use something like Aegis for security, Aegis for cluster. No, you cannot use the name Aegis because of this. All right. So what shall we use? We need to use Secrets Manager for this purpose. Then right now the official name is VMware Secrets Manager for Cloud Native Applications. and I cannot use it everywhere because like if you make a binary with that, nobody will type that binary. So, but those challenges, those are tied to being part of a large company, I guess, and I don't blame anyone in that regard because it is the processes are there for a reason essentially. But still, the navigating around those uh, guardrails, so to speak, was one challenge. Technically, it went pretty smooth. One technical challenge would be like I leverage a bunch of abstractions around this as well. Like I use cluster SPIFFE IDs, I use cluster federated trust domain recently, and I also use mm, the Kubernetes storage driver so that I don't have to mount, volumes. And in certain distributions like Ubuntu's microcates, for example, the storage CSI driver didn't work. So I had to bind straightly to the host path, essentially. Those are, little bits and pieces, but, still, a microcase is not a production grade, cluster. So it's a demo cluster. You would expect, not to have a proper driver working on it. But still, that might be later down the line something that we might prefer to add to what the SPIFFE CSI driver supports. And also, like some of those bumps could be just due to myself or to the team as well. Like maybe there's a way to make it work, but we didn't know. But because we didn't have time to investigate that alley. But yeah, like overall, it went pretty smooth, I can say.
Awesome. Yeah. I have no
Any
more
other?
questions.
Okay. Any other questions? Yay. Then thanks everyone. Hope it was informative. Like I knew that, the time was a little bit squeezed, so I had to rush through stuff. Again, another rep by myself.
No, this is fantastic. I'm really grateful. Thank you so much. This is really informative, especially just sort of the pathway to starting new projects in the open source community and.
Uh-huh. And for this, a federated thing, I have a separate recording, but there's no voiceover on it yet. When it's ready, I'll share in Slack so you can have a slower paced walkthrough about, how these clusters are set up and, what commands to type into like make it work. Along with source code, I'll put them somewhere, sometime, depending on, the madness around me.
Yeah, no, I understand. This is a side project, and you have a lot going on. So cool.
Definitely, like I can share some of those offline.
Yeah, all right.
It's crazy around me right now.
No, I understand.
Yeah.
All right. Awesome. Well, if there are no more questions, we can be done a little early. So, thanks everyone for joining, and keep in touch on Slack. All right.
Thanks, Dan. Thanks, Volkan.
Thank you.
Awesome.
Bye-bye.
Thanks, Evan. Bye.
Bye.